So now let's do the next part, which is the preparation of ethene in specific and the other alkenes in general. So now let's do the all methods of preparation. The first method of preparation is laboratory preparation. So laboratory preparation, like in the case of methane, you have a lot of conditions, a lot of reactants, temperatures also is very important to know. So let's just learn about that, and then we will learn about the other facts. So one thing that I want to mention is that the setup for the laboratory preparation is not tested. You don't have to learn the diagram. It's just for your understanding. So let's learn the details. So the first thing is nothing but your reactants. So your reactants to prepare ethene, which is the first member of alkene, will be ethyl alcohol and then concentrated sulfuric acid. So plus concentrated H2SO4. But then in the case of methane, what did we choose? We chose CH3COONA for preparing methane, and then we took soda lime, which is NaOH and CaO. So this is all, in case when you compare and learn, it will be easier for you to recollect what you have done before. Since you have a lot of equations, lot of methods of preparation, by the end of the chapter, you will have to revise you have to revise all the time. So if you recollect while learning every subpart, it will be easier for you. So the first thing is the reactants. We have revised in the case of methane, and then we have I've explained you for the case of ethene also. So next one is temperature. So temperature is supposed to be 170 degrees Celsius, or in terms of Kelvin is 443 to 444 Kelvin. So it's 444 Kelvin. While in the case of methane, the temperature is 300 degrees Celsius. So the reactants for the preparation of ethene is supposed to be ethyl alcohol, which is C2H5OH, and then concentrated H2SO4. And next is the temperature. The temperature is 170 degrees Celsius or 443 to 444 Kelvin. So since your textbook is they're given in terms of degrees Celsius, you can do. So next, let's go on with the equation. So there are totally two types of equation. One is the equation where they've represented in the form of two steps. The other one is just a direct equation where they've just written the two reactants and then the product. So generally they will ask only the last one, which does not include the two specific steps. But let's do both. So the first way of writing is in terms of two steps. So it will be C2H5OH plus concentrated H2SO4, which we write H2SO4 bracket conc. This is all you write, and then you write over the arrow as 170 degrees Celsius. Or if you want, you can write the same H2SO4 under the arrow in case if you don't show the two steps in specific. So the way in which you write is you have C2H5 as such. This is the first step, and then you remove OH, and then you put it as OH aside, and then you remove one hydrogen and put that hydrogen here. So when there's OH and then when there's hydrogen, it becomes water. So it becomes H2O. So you've removed one OH from C2H5OH and you've put it aside as a second minor product, and then you've removed one more hydrogen from H2SO4. You have added this hydrogen to that OH. So it becomes H2O, and you just still have the C2H5 left. So include this HSO4 and put it here. So this is supposed to be an unstable product. So it is known as ethyl hydrogen sulfate. So this is C2H5, which is supposed to be an alkyl group, which is known as ethyl. So this is hydrogen and this is sulfate, which is SO4. So ethyl hydrogen sulfate is an intermediate product. So what do you mean by an intermediate product? In case if a reaction takes place in two steps or more than two steps, the products in between the reaction, or in case if it is two steps, means the product in the first reaction, or in case if it is three steps, that means the product in the second reaction and the first reaction together are referred to as intermediate products. So this is the first step, and then you write C2H5HSO4, and now you add excess H2SO4. Now you add excess H2SO4, and then the temperature is going to be same 170 degrees Celsius here. Temperature is the same thing, and now you write C2H4, and that's it. You will get C2H4. So the next step is you will have to add these two things. So when you add these two steps, this will get cancelled and this also will get cancelled. So in the end, you will get the equation that is there in the condensed form. So it will be C2H5OH in the presence of normal amount of H2SO4 concentrated at 170 degrees Celsius will give you C2H4 plus H2O. So now let's check whether the balancing has been done properly. So this is 5 plus 1 6, and here 4 plus 2 6 hydrogen atoms, 2 carbon atoms, and then 1 oxygen atom. So now we have found the method in which you write the preparation of ethene in 2 different steps, and then you add up both the equations and you get a final equation where you have got C2H4. But this C2H4 is not a pure form of C2H4. There are a lot of impurities here. So like normally the methane that you get does not have impurities. So we do not remove there's no impurities for us to remove. So we don't have that extra step here. But here the ethene that we get in lab has impurities. So there is a way, and then the impurities in general are sulfur dioxide and carbon dioxide. So there are ways to remove sulfur dioxide and carbon dioxide because of the features possessed by them. So once again, the impurities present here are SO2 and CO2. These are the impurities. But there's a fact that SO2 and CO2 are supposed to be acidic oxides. SO2 is an acidic oxide of sulfur. CO2 is an acidic oxide of carbon. So you make use of this compound known as NaOH or sodium hydroxide, and then we know that sodium hydroxide is a very strong alkali. So when you get the gas and when you pass the gas through NaOH, when an acid reacts with the base, it forms a salt or it forms water. So normally formation of such things will lead to the removal of SO2 and CO2. So you have removed you have prepared using concentrated H2SO4 by making it react with C2H5OH. First part is done. Second part is removal of impurities, which is nothing but SO2 and CO2. Because of its high acidic nature, you make use of an alkali known as NaOH. So next comes your method of obtaining it. So like how in methane you make use of this method of obtaining obtaining the gas, which is known as downward displacement. Here also we make use of the same thing, which is known as downward displacement. So but then the reason behind this fact of using downward displacement is supposed to be it is inflammable in nature. This gas is inflammable in nature, and then it is insoluble in water. Like when you take methane, I would have said the reason why we use downward displacement of methane, it is very slightly soluble in water, and then it is supposed to be lighter than air. But I would have also mentioned that since it is very slightly soluble in water, you can also say it is insoluble. It is very slightly soluble. So it is very mild that you can also use the word insoluble. But when you take the case of ethane, it is supposed to be insoluble in water, and apart from that, it is supposed to be inflammable in nature. So these are the two reasons why we use downward displacement for ethene. So now the next, so we have talked about this, and next is while obtaining, one phenomenon can happen, and this is known as frothing. The frothing can happen. So what do you mean by frothing? Not in layman's words, when you take soap and then when you dip it in water and then when you rub the soap, you get a foam kind of thing, and this formation of foam is nothing but frothing in layman's language. But the same thing is observed while obtaining ethane by downward displacement of water, and I've already explained that we use downward displacement of water because of the inflammable nature and insoluble nature of the gas in water. So because of these two reasons, we use downward displacement. While downward displacement, frothing can happen. And so to avoid frothing, to avoid this, we make use of aluminium sulfate. So there are a lot of facts which you need to know. So I'll just give a very short recap. So first is the method of preparation, where you will make use of ethyl alcohol and then concentrated H2SO4, which generally occurs in 2 steps. The temperature is 170 degrees Celsius. So on adding the 2 steps, you will get the product C2H4, which is a major product, and H2O, which is a minor product. And this has many impurities, and then CO2 and SO2 are supposed to be the acidic impurities. So you make use of NaOH to remove the impurities. After the removal of impurities, next comes the process of obtaining the gas. So for the process of obtaining the gas, you make use of downward displacement of water. And I've already explained why you need to use downward displacement of water. So apart from that, to avoid frothing, we make use of aluminium sulfate.